Hello, today we are in London at the Humanoids Summit. Please introduce you.
Hi, I'm Michelle Liu. I'm the co-founder of Vsim.
What is your type of solution and what customer pain point does it solve?
So basically in Vsim, right, we are building the full stack solution for robotics. So start from simulation, right? As you see here, we have a proprietary simulation technology which can deliver up to 1,000 times faster than the existing solution for complex robot, right? And also we have what you see in here, we have a vision-based solution as well, right? So basically not just a physics simulation. Once we build this really unique platform, simulation platform, we build a robotics machine learning framework on top of it. That it means, right, we can utilize our simulation to generate tons of synthetic data in real time in order to train the robot. So what you see in here, right, is a vision-based policy. We're using our technology to train about 50 seconds. So 50 seconds, we are able to, this is a simulation test. Here, run the vision-based learning here. So sorry, you might need to cut it a little bit. But so basically, right, we are able to train the same policy in real time, right, 50 seconds. So if you compare with the existing solution, it takes hours to train. So
yes, and also if you have flexible randomized solutions.
Yes. So this is what you see in the trading exactly happening, right?
Yes.
So basically, we have 4,000 environment in here, right? Each one has the camera, and we domain randomize the camera image.
Yes.
Let the robot to learn that, right? Super efficient. So once this frame policy finished, right? It's roughly taking about 81 seconds because we are render at the same time.
Yes.
If we trade this headless, we are able to achieve a successful policy within 50 seconds.
And where?
Using just one GPU.
What is the state of your solution? Are you ready to go to market? Is this right?
We actually have a customer for it already. So our customer is including someone training a robotic foundational model, someone deployed in the physical robot, and someone using our system, right, to do a lot of vision-based learning. So what you see in here, right, after this finish, right, so the timing in here is a 60 seconds in here, and then you can, once this policy finish, we deploy that into this actual robot. So you can see here, right, basically the policy is the robot learn to take the input from the camera feed and then follow the cue. So you can it can adapt to different cue location and orientation. So it's a really general
I know this type of solution from other companies.
Yeah.
So where is it different, and what is the pricing of your solution when you sell it to the customer side?
So the difference is, for example, this kind of policy, right? If you take the existing solution, it takes hours to train, but for us, it's seconds. So clearly, you save a lot of computation power. You also save a lot of engineering time from the customer, right?
Okay.
So as for pricing point, at the moment, we're still trying to identify the right price.
Okay, because I'm interested because I'm working at the robotic side and with integrators at the industry side. Yes. So it's a really important point because otherwise you can't.
Yeah, absolutely. Let me tell you a story of our customer as well, right? So we have a customer who is trying to train a digital robot run on uneven terrain, right?
Okay.
So that is not a vision-based policy. It's a lot simpler than vision, right?
Okay.
So what they do is basically train the robot for 7 days, and then they have a GPU machine, right? So that a GPU machine is about $300,000. So let's assume they don't have that GPU machine, right? So now I'm trying to trade all this policy in AWS or whatever cloud platform, right? So the current price for that is about $2.50 per hour, right? So we calculate the time saving for that. It's about roughly $5,760,000 for just one locomotion task. So if that is just one task, if you trade a lot more generalized approach, right, that it clearly costs you a lot more if you want to trade this kind of policy on the data center. So Vsim is actually groundbreaking in that sense because we save you a lot.
Yes, you save a lot of time at the end of the day.
and the money of that, clearly.
Yes, clearly. And on the other side, you don't have the manpower to program the robot.
Yes.
That's also a big topic in Germany. We don't have enough employees right now.
Yeah. So yes, it's saving you lots of engineering time as well. So
Yes.
again, right, when you're talking about this policy, right, so sometime, right, we are talking about 50 seconds, but before you have this 50-second training, it's actually take you maybe hours to actually identify the right function for remote observation function, right?
Okay.
So if you calculate that, it's not just saving you few hours or week or something, right? Because you have the whole iteration time in there. So you're talking about saving you months of time and compute power like that. So that is our innovation.
Sounds really interesting, and I would...
And one thing I need to say as well, right? So we check it, right? A lot of people talking about sim to real gap because a lot of people talking about, oh, you're doing simulation, right? You train in simulation, but the simulation is different from the actual physical robot, right? So how do you bypass that? So our approach is basically put in simulation, we put a lot of randomization in there and generalize the policy. So what you're seeing in here is a zero-sum translation. So we train the policy directly deployed into the robot without any problem.
Sounds really promising. Can't wait to see you at the industry side.
Yes.
And wish you all the best here at this... sorry, I stuck at the Humanoids Summit right here in London.
Yeah. Okay.
Thank you for your time.
Thanks a lot.
Thank you.
Thank you.
Thanks.